Right, so guys, we are saying sorting in a linked list is usually cheap. Why? Because we have two options. We can change data items, then leave links intact, or we can change links and leave the data items intact. So sorting means arranging elements in either ascending or descending order from our usual definitions. So to sort elements of a linked list, we use any of the standard sorting algorithms that we know. You shall discuss about sorting algorithms, make sort, quick sort, and everything. All those sorting algorithms can also be used to sort data items in an array, just like they can be used in sorting data items in any other data structure. So while performing sorting, it is time to exchange. While performing sorting, when it is time to exchange two elements, we can adopt any of the following ways, right? Which is one, we can exchange the data part of two nodes, keeping the links intact, as shown in the diagram there, right? Or else, look at what happens there. We can keep the data part of the nodes intact, then we exchange we change the pointer or the links. So you find both ways make the linked list more efficient in terms of its ability to be sorted, because we are saying in each and every situation we decide what is best for us to actually utilize them. So now we can talk about recursive functions. When we're talking about a recursive function, we're talking about a function that calls itself during the time of operation. If a statement within a body of a function calls the same function, we call that recursion. So recursion does not apply only to linked list, but to most of our data structures. When we are doing sorting, when we are doing when we are doing sorting, we always use recursive functions to repeat maybe the process until sorting has been completed. Some of the operations are carried out on linked list can be easily implemented using recursion, right? Just like we can do it in other data structures. For example, finding out the number of nodes present in a linked list, comparing two lists, comparing one linked list, copying one linked list into another, and adding a new node or something like that at the end of the list. We are saying we can use what is called recursion. I want to believe that you know that in your programming, to say if a function calls itself, what does that mean? It actually means we have a function, but inside that function, we have that same function encapsulated within itself, that is calling itself programmatically. So ladies and gentlemen, I believe I've offered enough for linked list, but well, I faced the challenges in presenting this one. You see my diagrams were getting disfigured there, my files were getting unnecessarily large. I don't know what caused that kind of behavior to my application, and it is my sincere hope that you are going to understand this, that you are going to make a bit of effort to actually follow this. So guys, I have been using pictorial representations for each and every aspect that needs to be done in a linked list, so as to simplify matters. Now it is your duty to say, when you have this general understanding of linked list, you then go and retrieve the actual algorithms for insertion. Please go online, find the algorithm for insertion in terms of its pseudocode. Find the algorithm for insertion in terms of real code that can be used. Find the algorithm for sorting in terms of what we call the algorithm for, we have said algorithm for insertion, algorithm for deletion, algorithm for adding at the beginning, algorithm for adding at the end, algorithm for traversal, and all those things that we're explaining. You are supposed to find the algorithms in terms of pseudocode. Please find that online. Then you find the actual code, run code, test how it works. Here I've been simply giving you in terms of pictorial representation, so that you have a real logical understanding in your mind of what linked lists are and how they operate. So today I'm not going to come back here on app to teach you like I've been doing. Why? Because I'm facing challenges with my app here. So what I'm going to do is I'm going to lecture to you today on stats and queues. But I will simply give you a link because I will make one long lecture using my computer. Then I upload it on YouTube, and you are going to find it on YouTube. When you find that lecture on YouTube, I will say I have done my part in data structures and algorithms, and maybe I'm left with a lecture that I will do on Saturday, a live lecture on coding that I will do on Saturday. When I do that last lecture on coding that I do on Saturday, the remaining parts are sorting algorithms, searching algorithms, algorithm analysis and design. Those are the three topics that I'm leaving for you to do on your own. How can you do those on your own? You can volunteer as individuals to present here, just like I've been presenting to you. Then if we have 3 or 4 volunteers who then complete the main part of our module, they do it for you here. You understand, you throw questions here. This is time for you to do that. If you don't contribute, then it actually means you are going to read that part as individuals. I promise to come back to you again after I've completed my other modules. I may come back to make one or so more lectures to you. But for today, I'm not coming back here on app, but I'll simply throw a link of the lecture that I will do. I'll present it as a complete lecture. Then I upload it on YouTube. That will be a lecture on stats and queues. From there, I believe I would have covered, if we do the Saturday lecture, I believe I would have covered almost more than half of the module content. And you are left with very little that you are going to do on your own. And please contribute here. If you have a chance, present your small topic, say LinkedList, then what we call it, make sort, say maybe you want to talk about bucket sort, quick sort. You are finding sorting and searching algorithms that are within your module. Then you present them here. You make discussions as I listen to you. Then you are through. But I'm sure I've covered a number of elements within our module, and I'm going to do one more lecture today. When I do that one more lecture, I'm done. I will then meet you on Saturday. When I meet you on Saturday, I say to you goodbye. I will then meet you after you have written your last assignment. Maybe we can discuss, revise here and there in terms of preparing for the examinations. Now I want to cover other modules. This is not my only module. So please, ladies and gentlemen, 1, bring assignments on time. 2, contribute here on the platform for the betterment of your learning. Thank you very much.